Dr. Radha Subramaniam. So I think you all will be very busy in doing your last minute preparations for the upcoming Neet exams this day, and you might all have finished your preparations, and let us quickly go through a trick to solve position isomerism and chain isomerism today from chemistry NCERT. Okay, so first of all let me briefly tell you what is meant by isomerism. So it is nothing. Isomerism, here two compounds with same molecular formula but different physical and chemical properties. These are called isomers. See, when you consider two compounds, their molecular formula will be the same, but physical and chemical properties are different. So these are called isomers, and this phenomena we call it, this process we call it isomerism. For example, we take this C2H6O. Here the molecular formula is what? CH3 CH2OH, and here also see this is alcohol, okay, because OH group is the functional group here. So this is alcohol and this is liquid, but here the same molecular formula. See here this is also C2H6O, but you know we write this as CH3OCH3, okay. Acetone, this is an ether, and this is a gas. Okay, now see the molecular formula are same, but the structure it is different, okay. Now let us see the properties of alcohol. See what happens when it reacts with HI. So when it reacts with HI, it forms CH3CH2I, okay, and if it reacts with sodium, then you get hydrogen gas. But at the same time, take the case of ether. What happens when it reacts with HI? Here we got CH3CH2I, means with ether the product formed is CH3I, but and reaction with hydrogen, it does not react with hydrogen. So see, the physical and the chemical properties are different. Both are alcohol and ethers, both are isomers, since the molecular formulas are same, but physical and chemical properties are different. So in a nutshell, we can say this quickly about isomerism, and taking alcohol and ether as example, we understood what it means actually. Now see, at least one property is different, then also we call them isomers. So isomerism, there are main classification, structural and stereoisomerism, and here structural isomerism means compounds with the same molecular formula but different structures. Again it can be classified into chain isomerism and position isomerism. So today we are going to learn mainly about chain isomerism and position isomerism. Listen carefully when I tell you, okay. So I am trying to explain it in a simple way as possible, because during last minute revision you should not get confused with the concept, okay. And even NCERT class 12 students also can go through this when you do the preparation for the next 2023 Neet exams. For you also it will be really useful. Now let us see what is meant by chain isomerism. So two compounds, their molecular formula being the same, but parent chain size are different, or side chain size are different. So see here, this is normal butane, CH3 CH2 CH2 CH3. So we will number like 1 2 3 4, we are numbering the carbon atom. So parent chain is the longest chain, which has 4 carbon atoms, 1 2 3 4, okay. Now here what is this? This is 2-methyl propane, CH3 CH CH3. Here also the same thing only, but we are writing it like CH3 CH, here also CH3 CH3, fine. Now when you number the carbon atom 1 2 3, so the parent chain has only 3 carbon atoms. So parent chain is different. Here in these two cases the parent chain is different. So that is what we call as chain isomerism. Now let us see what is meant by position isomerism. That is when two compounds have same molecular formula, parent chain size is same. For chain isomerism, parent chain size was different. So here the parent sizes, chain size will be the same, okay. But side chain size, what happens, that is parent chain size is same and side chain size is also same, but different position of functional groups, or multiple bonds or substituents. So that is the difference between chain isomerism and position isomerism. Parent chain in position isomerism, parent chain size same, side chain size is same, but position of functional group or multiple bond or substituents are different. Let us see this example. CH3, CH2, CH2, CH, CH3, side chain is also CH3. When you number it, see the side chain which is attached, the branch should get the lowest possible number. So we number from right to left only, then see the side chain gets the lowest possible number, which is 2. So from right to left we number it 5 carbon atoms present in parent chain. Okay, so here also we number. Here either way you can number it because it's the side chain is coming in the middle. So here also parent chain size both 5 carbon atoms are there. Let us see the side chain, both are CH3. That is also same, but see the position. Here the side chain is attached to position number 2 and here it is attached to position number 3. That is different. So that is why this is called position isomerism. Now we will see the trick for isomerism. Molecular formula same, then chain isomerism, parent chain or side chain will be different. Parent chain, if for position isomerism, parent chain or side chain will be the same. You remember these 3 points, okay, and position functional group, multiple group and substituents will be different, okay. Now see this question. So 1 and 2 here, the first one CH3, CH2, 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 CH3, and here see both here how many carbon atoms? 5 carbon atoms, okay. This case see like this, and for the second one CH3, CH2, CH2, CH, CH3 and CH3. See parent carbon atom has got the number of carbon atoms are same. So you can see according to this that this is chain isomerism. Parent carbon atom, these are chain, and here see, just look at this example. See here functional group is also same. So what were the conditions for chain isomerism? That is same molecular formula, parent chain size are different or side chains are different. Here side chain is different, see, but for this case see CH3, CH2, CH3, side chain is CH3. CH3, CH2, CH, CH2, CH3. When you number it, this should get the lowest possible value from left to right. 4 carbon atoms in the parent chain. Here, either way it is okay. 5 carbon atoms are there, and here this is position isomerism. See what is said for position isomerism? Parent chain or side chain are the same. See both are CH3, but functional group, multiple bond, these are all different. Okay. So from this example you can understand this is example for chain isomerism and this is an example for position isomerism. That is functional group position is different. For this case in position 3 the side chain is attached, here it is 2, side chain is 2, okay. So this is called position isomerism. Now we will see 1 or 2 more examples. See this case here, see 1, 2, 3 carbon atoms for both the case, same side chain here, see, and parent chain is also same. See 3 carbon atoms, side chain has got only 1 carbon, okay, here 1 carbon but here 2, so position is different. This is position isomerism. See what about this case here? See here 6 carbon atom, parent chain it is the same. So side chain here also 2, here also 1 1, see here side chain this is 2 and here it is 1 1, different side chain. So this is chain isomerism. Clear? So I hope you know, even though we had a quick and brief revision of the topic, I hope you will find this clear and easy, and just keep on with your revisions and do your exams well. All the best to you, and we will be coming with more videos in future also. And for those of you who are going to appear for Neet 2023 and 24 can subscribe and like, share and subscribe to the channel Chemistry for Neet, and thank you all for your support so far, and thanks for watching the video.